Hello everyone, I'm Rajit Oza. Right now I'm handling National WASH-MIS of Nepal, and today we'll be presenting few novel initiatives that we're trying with the help of FCTO, where we'll be talking about the optimization possibilities with artificial intelligence and machine learning. We check the possibility and the results have been encouraging. So right now we are collecting the data on project inventory and sustainability, where we take the asset related data on water supply systems. We also collect the household questionnaires where we take the information about the household toilets and washing stations, which will be used later on for the SDG 6.2 reporting. We also track the on-site population. The data are geo-referenced. We also track what's in school and healthcare facilities. We also track the public toilets. Almost all of the data are fed into the system, which later on takes the indicator of joint monitoring program indicator developed by WHO and UNICEF, which later on be used to find out the status of those local governments. So based on that one, we calculate the status. The goal has been determined based upon the sustainable development goal. Then the investment is calculated and the financing option is also integrated inside the system. So this is the example of one of the local governments where we have calculated the safely managed percentage of population, basic percentage of population, limited, unimproved, and no service level of population based on the JMP indicators. Then we have calculated the investment requirements for the capital investment, capital maintenance expenditures, operation expenditure, and direct support. So these has been automated inside the system. So then we go to find out what can be the possible financing options, which is also integrated inside the system, where we talk about the tariff, tax, transfer of the local governments. Similarly, we try to give them the alternate options such as like trade, repayable financing, shares, equity, bonds, CSRs to be comfortable with the financing arrangements later on in terms of WASH planning. So these are the the information on how much data we have collected so far. So we have collected more than 20,000 water supply systems data, which covers more than 7 million population. Household coverage is more than 1 million. Ongoing projects also, the data has been collected on ongoing projects and proposed projects. Also, we have identified the unserved communities, and all these data are geo-referenced. Similarly, in sanitation, we have the household sanitation related data, the community sanitation related data, where we talk about the fecal loss treatment plants, wastewater units, solid waste management. We also have the washing institution related data and public toilet related data. To have the kind of a system approach, we have covered the wash governance data also inside our system, where we know where local governments are in terms of achieving those processes to reach the safely managed wash services. Similarly, we also collect the water quality related data. So these are the agencies which are like the agency mapping, where the agencies are supporting us in covering the whole nation. This is going nationwide, and we have been able to formulate more than 200 local wash plans based upon these guideline and these frameworks. So the excess of NWASH has more than 7,000 users, means more than 7,000 users have been using NWASH to formulate this database. So definitely these numbers of users um, are going to formulate, mm, are going to help us in creating those WASH related database. And there are like few possible expansion possibility we have seen, where we can analyze the WASH market, which can be the dashboard for the private sector. We can integrate the early warning systems, and we can also formulate the capacity development master plan for the local governments. But these all things comes with the few problems which we are trying to encounter through the novel initiatives. This is the mass data collection, where the enumerators are heterogeneous, more than 7,000, and enumerators are heterogeneous and very difficult to validate and find the data risk. Most of the data are perception based, so it becomes more enumerator dependent, and the approximations becomes like more enumerator dependent, and every stakeholders has different data needs. So based to mitigate those, we try to use the AI to identify what our systems are in terms of image. when we collect the georeference data, we have the image also, and we try to see whether those images can be used to mitigate those problems or not. So maintenance condition mentioned in NWASH can easily be identified uh, according to the research, where we were talking about the good, minor repair, major repair, and rehabilitation based upon the perception. Now we can see what actually the structures have in terms of problems. Similarly, some of the questions were not asked during the survey and had very important analysis in terms of asset management, such as like sanitary condition, can also easily be identified when we use the image processing. Similarly, there are like other questions which were not asked, like child friendly, whether the tap is child friendly or not, whether it is easily accessible to disabled people or not, also can be like some of the data can be approximated through using these images. Similarly, options can be tried out to carry out in public toilets as well, where monitoring is difficult and human resource consuming. Here you can check the disability, you can check the cleanliness of the public toilet if you use these images as the data sources. So also like if the toilet is substandards, that also can be easily tracked through machine learning and AI. So based on this one, we have seen mm, through this research that these can be very innovative options. These can be tried out, and the data can become more data's quality can be more enhanced through this initiative. And for again, I would like to thank for the opportunity that you have given to present this presentation here. Thank you very much.